Welcome to Trains, Rainbows, Muppets, and the Expanding Universe. A brief discussion of the interconnection of things. Today, let's start with trains. Yes, we all know just a little bit about trains, or a lot of bit about trains, but most of us remember either from being near railroad tracks or watching a television of hearing that sound of the train starting at a very high pitch coming toward you and a low pitch going away, sounding something like And if you also remember back from high school science, someone called that the Doppler Effect, named after a fellow named Christian Doppler who lived at the beginning of the 1800s. That high-pitched noise as you comes toward you, that's because the sound waves are sort of being compressed, seeming shorter and shorter as they come toward you. And then, as it's running away from you, they get stretched out or become longer. And so that's why it sounds a little bit higher as it comes toward you and then begins lowering in pitch after it's past you. The trains and the Doppler effect. Well, that's piece one of this little discussion. Now, on to piece two, and we go backwards in history. Christian Doppler was from the beginning of the 1800s. Well, we're going to go back to the 1600s, and a fellow named Sir Isaac Newton. You probably remember him. He's the fellow who discovered sort of how gravity works, as well as coming up with calculus. I'm not hearing any cheers for calculus at this moment, but Sir Isaac Newton did more than that. In 1666, he wrote a book on optics, specifically studying light's properties for things like going through a prism and coming out as a Pink Floyd album, Dark Side of the Moon, also known as a rainbow. He also discovered he could take this rainbow, focus it, and put it back through the prism, and would come out as a beam of white light. He made many advances in observations on light, optics, and its principles. Many, but he happened to ignore a few things. He made notes about them, but didn't think they were important, apparently. And this really wasn't discovered until the 1800s again by a person named Bunsen. Well, no, sorry, not the Muppet Bunsen Honeydew, the Muppets' resident scientist. I'm talking about a different Bunsen. I'm talking about Robert Bunsen. Robert Bunsen was a scientist very interested in gas and its properties. Going back to high school chemistry again, you may or may not remember the Bunsen burner, that little thing sitting on the lab table when you had to finally heat something. I think they allowed me to use it a total of 3 times while I was in sophomore chemistry. But it was Bunsen who looked at Newton's rainbow and noticed what was missing. If you think of a rainbow, it should just be a continuous spectrum of light, doing that Roy G. Biv. Roy for red, orange, yellow, G for green, and Biv for blue, indigo, violet. But it wasn't a continuous spectrum. When you aimed it at something like the sun, it was more like the bottom spectrum there, where there were missing pieces, little bits that were taken out. Well, he'd pointed at the sun and noticed things were missing, and he'd pointed at other lights that were burning. If he was burning hydrogen gas, if he was burning whatever, he'd begin to look at it and notice, hey, each of these lights, little different bits and pieces are missing. And what he soon discovered was that it was consistent depending on what was producing the light. And he began to realize, and other scientists agreed, that you could understand what chemical reactions were occurring, basically what was burning, to create the light. And they would aim it at our sun and say, hey, look, hydrogen over here. At another sun and say, look, helium, look, iron. All sorts of things they were beginning to look at and beginning to understand more of the universe just by those little pieces missing from the spectrum. But what they weren't really expecting is that as they began to look out into the universe at stars, if the star was nearby, the thing was really pretty stationary, wasn't moving in relation to us. and they could look at it and everything matched up. But they began to notice things didn't match up. It should have been helium, but all those little breaks were too far over to the right or too far over to the left. And that's when they began figuring out the stars were moving. If it was coming toward us, well, it was like getting a higher pitch from a train. It would sound higher, or in this case, the lights would be at a higher frequency. If it was going away from us, it'd be lower pitch or a lower frequency, more in the red. These are sometimes referred to as blue shift and red shift. Well, this was interesting, but then they noticed another thing. When they looked at stars around us, stationary, little few receding, few approaching. But when they began looking at the galaxy, everything was redshifting. Everything was going away. And it wasn't just in one direction, it was in all directions. Everything all around us was moving away. And that's when the scientists began to realize the galaxies, the universe, is expanding. That big bang that started everything off was still in effect, pushing things away. Now, if you stop and think about it and go back to Sir Isaac Newton and gravity, you got to realize if you just take a planet and sort of let it go and say, don't move, gravity's going to take over, and all those stars and planets will just begin pulling back into each other and collapse. So something has to be happening to keep them from just falling back into each other, and that is our expanding universe. And so that's why trains and the Doppler effect. Sir Isaac Newton and his rainbows that then became Robert Bunsen and his rainbows, and the expanding universe are all connected.